Welcome to this webcast on using ANSYS Products on the HPCBOX platform. We'll look at how you create a cluster, use ANSYS Fluent, ANSYS Workbench, CFX, and CFD Post. HPCBOX clusters for ANSYS can be created on the Azure portal through the Azure Marketplace. You'll be asked to provide a few basic options and provide the settings required for your master and worker nodes. You can select the size of your master nodes, the GPU nodes, the compute nodes, the amount of storage you want to use for your home directories, and the type of storage you want to use. Once you provide these options, the Azure portal is going to validate these options, and once it finds that these options are valid, it'll go ahead and create an HPCBOX cluster with all the ANSYS applications preloaded onto it. Once your cluster is created, you can use the HPCBOX Connect App to get access to your cluster. It's a pretty simple application. Once you're logged in, you can click the desktop button here to start the remote desktop tool and access your cluster. You'll see that all your ANSYS applications are pre-installed. You'll also see that you've got the HPCBOX cluster app. This app is used for creating your workflows and also controlling your underlying infrastructure. It's got a set of tools. For example, there is this RDMA tool here. It comes in very handy in order to test the InfiniBand fabric on the cluster. You can use this tool to make sure that the interconnectivity between all the compute nodes is working as it should. You also got the ANSYS license administration tool. This tool helps you configure connectivity to your existing ANSYS license server, or you can install a fresh ANSYS license server right on the cluster. So let's see how you can create a workflow with ANSYS Fluent. So you've got this different applications here on the left in the application area. You can see that you've got something called cluster control. So cluster control lets you perform various elasticity options on your cluster. For example, you can add nodes to your cluster, you can shut down nodes, you can remove nodes, and you can include these operations as part of your workflow on the HPC cluster. So for example, I could say, well, add compute workers, add like 4 of them, and then once that is done, I can say execute ANSYS Fluent, and I can provide options for ANSYS Fluent. Then once that is done, I can say execute ANSYS CFD Post, and then I could say run cluster control again, and then shut down all your nodes. So you can assemble all the applications available here and create a chain of applications and then submit that, and an HPCBOX cluster app is going to execute them each one by one. You can also look at your past workflows which you run. You can get details about your cluster. Let's see how we run ANSYS Fluent. We drag and drop ANSYS Fluent onto the workflow editor. We select the working directory. We select the version of Fluent we want to use, the number of CPU cores. In this case, it's going to be 32 cores, and any additional options which I want to provide ANSYS Fluent. So what you'll be able to see is that ANSYS Fluent starts up in parallel with its native graphical user interface, and this will allow me to use ANSYS Fluent just as I would on my local workstation. You can run Fluent in both batch mode and graphical interactive mode, and you'll also be able to execute journal files, etc. So in this particular demo, I'm going to be executing a journal file which is going to load up a sample ANSYS Fluent case, perform some operations on it, so you get an idea of how you can use Fluent on the HPCBOX platform. So you can see here that we're able to look at all the residual plotting, and we're also able to look at all the velocity vectors and just use Fluent as we would on our local workstations in graphical mode. So this makes it very easy for end users to make a transition from their local machines onto a cloud-based system like HPCBOX because they don't need to learn any new techniques or learn how to use web forms to submit jobs. Okay, so we have seen how to execute ANSYS Fluent on an HPCBOX cluster. Now we'll see how we can use ANSYS Workbench and execute a workflow which will also be controlling our underlying cluster infrastructure. So you've got ANSYS Workbench installed, and you can find the shortcut here on your desktop. You can start Workbench. It's going to start Workbench just as it would on your local machine. I've got an existing case here, which I'm going to load up. So you can see here that there is a component system here called HPCBOX. So this component system in ANSYS Workbench lets you optimize your underlying HPC infrastructure before and after every step in your simulation workflow. So in this case, what you see here is you've got the HPCBOX cluster control. I can ask ANSYS Workbench to use this connector and then start up all the compute nodes on the cluster. Or if I wanted, I could add additional compute nodes onto the cluster, and ANSYS Workbench would use the connector, add additional nodes, so you can scale out your cluster, and then it would start the CFX solver process. And then in order to shut down the nodes once the solver process is done, you can use the third component in this workflow, and you can ask this controller to stop all the compute nodes once the solution process is done. So let's see how this works. So I'm going to select compute workers, start, and then I'm going to select set up the properties and preferences for the CFX solution part. I'm going to say use the remote solve manager in order to run the solution. And I'm going to say use 32 CPU cores, and I'm going to have all the nodes shut down once the workflow is done. Okay, so now my workflow here is set up, and I can ask ANSYS Workbench to execute this workflow. So you can now see that the first part of the workflow is completed, and now the CFX solution part has just started. You can open up Job Monitor here, and we can see that the CFX solver job has been submitted through RSM to run on the underlying HPC infrastructure. You can also see that it's selected 4 different nodes, and they're all interconnected with an InfiniBand fabric. HPCBOX supports both hardware-accelerated remote 3D rendering and GPU computing on worker nodes which are equipped with an NVIDIA graphics card. So let's see how we can perform post-processing operations using CFD Post on HPCBOX. We select the working directory for CFD Post here, select the version we want to use, and we ask HPCBOX to use a node which has got an NVIDIA GPU card and start the CFD Post process on that particular node. So once we hit the start button, we can see that CFD Post is going to start with its native graphical interface just as it would on our local workstations, and we can perform all our post-processing operations right on the cluster itself. This is going to be very useful in avoiding large data transfers because we can load up our results, perform our post-processing on the cluster itself, and we can avoid having to bring back all the result files to our local machines to perform post-processing on them. This is very useful in saving network-related charges on our HPC resource on the cloud. Thank you for watching this webcast. and get in touch with us to start using HPCBOX.